This video was made possible by CuriosityStream. Watch thousands of high-quality documentaries and get access to my streaming service, Nebula, using the link in the description. In the fall of 1964, the Air Force begins testing a radical new machine that looks like it's come from outer space. It's one of the fastest aircraft to ever fly. A massive intercontinental bomber that can outrun any fighter jet. An aircraft so groundbreaking, it rides its own supersonic shockwave. It was going to be the future America's bomber force, but efforts to develop such an advanced aircraft would be marred by tragedy. By the mid-1950s, tensions between the United States and Soviet Union were reaching an all-time high. Both sides had strategic bombers that could fly halfway around the world to strike targets deep within enemy territory. The United States had developed a state-of-the-art, all-jet bomber force. The newly introduced B-52 could carry large payloads over long distances, and the soon-to-be-introduced B-58 would dash to supersonic speeds. But in an all-out conflict, neither of these would really cut it against Soviet air defenses. While the B-52 could fly all the way to the Soviet Union, it flew too slow to stand a chance against the latest generation of Soviet interceptors. The supersonic B-58 could just fly as fast as any interceptor, but had limited range and payload. What the Air Force urgently needed was a new kind of plane. A heavy bomber fast enough to outrun anything the Soviets could throw at it. But in 1955, many doubted whether such a plane was even possible, because it would mean having to turn to some pretty radical solutions, like using nuclear power to extend an aircraft's range, or exotic high-energy fuels to boost the performance of jet engines. The most practical solution seemed to be an aircraft that would fly subsonically most of the way to its target before jettisoning the outer portions of its wings and fuel tanks to make a supersonic dash. But aviation technology in the 1950s progressed at a breakneck speed, with rapid advances in aerodynamics, engine performance, and exotic materials. And it meant that the dash concept could be shelved in favor of a design that would cruise supersonically over its entire mission. So in 1957, the Air Force began development of a next-generation bomber, and the performance targets were ambitious. It would have to fly more than 3 times faster than the B-52, 25,000 feet higher, and have a similar payload and range. Leading aircraft builders Boeing and North American Aviation were invited to compete on a design. Boeing and North American submitted radical concepts that looked similar on the surface. Both featured Cunards and slender delta wings optimized for supersonic flight, but Boeing was widely expected to win. After all, they had built the venerable B-52 and a series of iconic bombers during the Second World War. North American was the underdog. But during development, their engineers stumbled upon research that would give them a huge advantage. A little-known report that detailed a phenomenon called compression lift. When flying faster than the speed of sound, shockwaves typically travel away from an aircraft. But if they could be redirected underneath the wings, the shockwaves would help generate additional lift. Using this principle, North America's entry promised to fly more efficiently at high supersonic speeds, and the Air Force was impressed. To the shock of Boeing, in 1957, North American's design was selected for development. The new bomber would given the name Valkyrie and designated as the B-70. Engineers used cutting-edge technologies to build a 260-ton bomber that could outrun a fighter jet. To make this feat possible, 6 afterburning turbojets were fed air through a sophisticated intake. The engines were optimized to run most efficiently at high supersonic speeds, and they were powerful enough so that even if one were to fail, the Valkyrie could maintain Mach 3 and still complete its mission. But clever aerodynamics were also key to performance, with compression lift giving the Valkyrie one of the highest lift-to-drag ratios of any manned aircraft. Variable geometry wings improved stability and enhanced compression lift. On takeoff and landings could be fully extended at low supersonic speeds, angled downwards 25 degrees, and at multi-Mach speeds a full 65, but flying at 3 times the speed of sound. Kinetic heating the airframe would be so intense, it would soften conventional aircraft aluminum. So engineers developed a revolutionary fuselage skin and circulated fuel throughout the airframe to cool the aircraft's interior. Even at an altitude of 75,000 feet, the Valkyrie's cockpit was fully pressurized and featured an innovative encapsulated escape system. It meant that the bomber's crew of 4 wouldn't have to put on bulky flight suites, allowing a Valkyrie crew to get airborne only 20 minutes, capable of delivering a nuclear payload to anywhere in the world in just hours. The Valkyrie's performance was truly out of this world, and the bomber would embody America's strategy of deterrence through strength. The first experimental XB-70 prototype was unveiled in May of 1964 with flight testing to begin in the following months, and it would soon be joined by a second and third prototype, both already under construction. But from the start, it was clear that things wouldn't go so smoothly. During initial ground tests, there were so many technical problems. The first flight was delayed for months, while engineers sorted through a laundry list of issues. It wouldn't be until September 21st that the XB-70 was finally ready to make its first flight, and cheers could be heard as the space-aged bomber lifted off for the very first time. But celebrations were short-lived, because a hydraulic leak prevented the landing gear from retracting. And soon one of the engines surged, forcing a shutdown. As the prototype came back in for a landing, a brake locked up, causing a tire to blow out and catch fire. It seemed just as one problem was solved, more would emerge. On October 12th, the XB-70 crossed the sound barrier for the very first time, just barely, inching above Mach 1. But as flight tests continued, paint began peeling off the fuselage and control surfaces, and soon the aircraft looked like it had flown through a sandblaster. The paint was patched up, and the XB-70 pushed on to higher speeds. But with each test flight, it seemed the faster it flew, the more serious the issues became. On its 12th test flight, as the prototype reached Mach 2.6, the horizontal splitter tore off and was sucked into the engine duct, knocking out 4 engines. The pilots landed safely, but all of the engines had to be replaced. Finally, on October 14th, the aircraft was cleared to reach Mach 3. But just 2 minutes in, a large portion of the wing's leading edge broke off, forcing yet another emergency landing. From that point on, the first prototype was limited to flying no more than Mach 2.5. In developing such a state-of-the-art aircraft, there were bound to be setbacks. But there was a much bigger problem looming over the program. From the very start, there were serious doubts about whether the Valkyrie would really be safe from Soviet air defenses, because surface-to-air missiles, introduced in the mid-1950s, were quickly becoming the most effective way to guard airspace, and by the 1960s, the Soviet Union had thousands of them, which could hit targets beyond even XB-70's altitude. The introduction of ICBMs in the late 1950s also meant that nuclear warheads could now be delivered much more quickly and economically. In the span of just a few years, missile technology had rendered the world's most advanced bomber virtually obsolete. With XB-70's strategic value in serious question, engineers scrambled for ways to keep the plane relevant, sketching out radical concepts to repurpose the bomber into missile launcher, an aerial launch platform for spacecraft, or even a supersonic aerial refueler. Even more outlandish was a proposal that would turn the bomber into a Mach 3 supersonic transport. But these concepts proved to be a bridge too far, and the program was dramatically scaled back, eventually reduced down to a bare minimum research project involving just 2 aircraft. But with millions already spent on development, the program pushed forward, and in 1966, NASA joined the Air Force in flight testing, using the prototypes to gather valuable research into supersonic flight. By that point, the second prototype had proven to be a much more capable plane. On May 19, 1966, it reached speeds beyond Mach 3, demonstrating its ability to cruise at 3 times the speed of sound over 30 minutes. After nearly a decade of development, one of the world's most ambitious aircraft was finally living up to expectations. But tragedy would strike just weeks later. On June 8, the second prototype was joined by 4 other aircraft for a formation flying photo op. But minutes into the flight, without warning, one of the trailing aircraft collided with the XB-79, instantly destroying it and severely damaging the Valkyrie's vertical stabilizers. For 16 seconds, the Valkyrie continued flying straight and level before spiraling back to Earth. In a matter of seconds, 2 test pilots and a billion-dollar aircraft were tragically lost. It was a devastating setback for the program, and it meant NASA and the Air Force would have to continue research with the much less capable original prototype. The XB-70 was an engineering marvel, and while it never joined America's bomber force, it still had a profound impact on the Cold War, because in 1955, when the Soviet Union learned that the Americans were developing a supersonic, long-range bomber, they scrambled to develop an equivalent, and it would end up as one of the most fearsome-looking aircraft ever built. But looks can be deceiving. In an effort to match Americans, the Soviets ended up producing an embarrassing failure, one that they would keep hidden for decades. You can learn more about the M-50's dramatic failure in my latest video available right now on Nebula. Nebula is where you watch more mustard videos, like my video on the legendary F-117 Nighthawk or MiG-31 Foxhound, and it's where you can enjoy exclusives from other creators like Real Engineering's incredible news series on the Battle of Britain, or nearly 3 hours of exclusive Nebula content by real-life lore. The best part about Nebula is that it's free when you sign up for CuriosityStream, a streaming service with thousands of big-budget award-winning documentaries. A recent favorite of mine is Finding the Graf Zeppelin, a fascinating documentary about Germany's WW-2 aircraft carrier, at the time the world's largest. You can learn why it was Germany's first and last ever carrier.